Hello and welcome to my video. Today we are going to find the integer solutions to the given equation. So the equation looks like this. Pi to the power of x over pi to the power of y equals pi to the power of x over y, where this pi is the famous irrational number 3.14159. But this pi is really not that important. So let's solve this. By the exponent rule, we can write the left-hand side as pi to the power of x minus y. So the equation simply becomes x minus y equals x over y. Now we multiply both sides with y, but in doing so we must be careful. The original equation contains x over y part, which is undefined at y equals 0. Therefore, y equals 0 cannot be the integer solution to the given equation, even if it is obtained in the following process. So just for the sake of the reminder, let us also write that down. So we have xy minus y squared equals x, and y cannot be 0. So where do we go from here? Well, let us compare the degrees of two unknowns. You can see that the given equation is now linear for x, which means first degree, and quadratic for y, which means second degree. This means that we can easily solve this equation for x by simple rearrangement. So we have xy minus x equals y squared. So y minus 1 times x equals y squared. So therefore, x equals y squared over y minus 1. And of course, y cannot be 1. So we have this, and we must somehow use the integer conditions. That is, this x must be an integer. We can make good use of such condition if this numerator part is some constant. So in order to make the numerator constant, we divide the numerator with denominator, or in this case, the much easier way is simply subtracting 1 and then adding 1 at the numerator. So now we have y minus 1 times y plus 1 over y minus 1. Therefore, we have y plus 1 plus 1 over y minus 1. So now we have the constant term at the numerator. Since x must be an integer, this 1 over y minus 1 part must also be an integer. So y minus 1 must be either 1 or minus 1. This means that y equals 2 or 0. However, I have already mentioned that because the original equation contains y at the denominator, y cannot be 0. So the only possible value is y equals 2. And from this expression, x equals 2 plus 1 plus 1 over 2 minus 1, which is 4. And this is the integer solution to the given equation. Thank you for watching, and I will see you in another video.